In this video, we'll be discussing integration with limits in layman's terms. So I will first lead with the question. We have a board that is 4 inches by 6 inches and has an area of 24 inches squared. We have another smaller board that is 4 inches by 3 inches and has an area of 12 inches squared. If we were to place the smaller board on top of the other board, how could we possibly find the area that is not covered by the smaller board? That's right, we can take the area of the larger board and subtract the area of the smaller board to get 12 inches squared area of the larger board not covered by the smaller board. Now let's put these two boards on a graph. The shared height of 4 inches will be what we set y equal to. Now how do we go about using integration or finding the area between the equation y equals 4 and the x-axis to solve this problem? Well, we have a constant 4 that needs to be integrated between length x equals 6 and length x equals 3. Integrating using the constant rule, we are left with 4 times x being the desired lengths. For example, when taking a limit, we take the top value plugged into the equation minus the bottom value plugged into the equation. Plugging in our numbers, we get an area of 12 inches squared. Now let's do the same problem, but this time we place the boards vertically. How do we graph this? We would graph it with y equals 6 for the larger board and y equals 3 for the smaller board. What would the integral look like for this one? We would take the integral of 6 length from x equals 4 to x equals 0 for the first board, then subtract the second board's integral of 3 length from x equals 4 to x equals 0. Completing the integral using the constant rule, we are left with 6x minus 3x, and this is all from the limit of x equals 4 to x equals 0. So plugging in all of our numbers, we are left with the displayed equation that once again equals 12 inches squared of area. To help with your intuition on how area works with definite integrals, I have a graph of y equals x and y equals negative x on this slide. Integrating this, we get 1/2 x squared, positive and negative respectively, which is graphed to the right. This shows that if the area between the equation line and the x-axis is above the x-axis, it is positive area when using limits. So if the equation is in quadrant 1 or quadrant 2, the area is positive. This means that on the integral of x and negative x graph, the equation line will increase in value. If the area between the equation line and the x-axis is below the x-axis, then it is negative area when using limits. So if the equation line is in quadrant 3 or quadrant 4, the area is negative. This means that on the integral of the x and the negative x graph, the equation line will decrease in value. You might want to pause here for a minute and take this all in. That concludes this video. Hopefully I've earned a like, share, or subscription. If you enjoyed this video, you may enjoy one of these videos as well. Let me know how I'm doing in the comments down below. Thank you for watching.